This is my diagram of the power system. So to start out with, we're going to start over here with the battery. So I used this example from Hobby King battery as an example to use in my diagram. So it's a 5 amp battery, or 5,000 milliamp. The voltage, since it's 4 cells, and each cell would be 3.7 volts. So overall, it is 14.8 volts. And then its C rating is 70 C with a burst C rating of 140 C for the discharge. So I've done some math down here. As we look, we take the milliamp hours and we divide by 1,000 to get the 5 amps, which we can also see right here. And that is equal to 1 C. So since this one is a 70 C, we times that by the 5 amps and we get 350 amps that it can output. Or for its burst rating, we take the 140 C and we times that by 5 and we get 700 amps for the burst rating. So if we know how many amps the rest of our system can take, particularly the motor that we'll talk about later, then we can find a battery that can handle that much output. So up here we have our charging lead, no, I can't remember the exact name of it, but the balance charger, that's what it is. So as we can see, there are 4 wires plus the ground wire. So each of these wires will connect up to a different cell in the battery. And then we have our main lead, or our discharge lead, depending on what you want to call it. So when it charges, this will take in most of the volts until it gets down closer to all of them being fully charged. And then the balance lead will charge them the rest of the way to make sure they're all balanced and our battery is properly taken care of. And as we can see here, we have 2 different colored wires coming out. From our legend, we can see that the red wires are positive and the black wires are our ground. So next it leads to our power module. The power module, it regulates power for the rest of the system. So we have one set of leads that go to the power distribution board and provide power to it and the rest of the system. And then another set of leads that lead to the flight controller and provide power to it and to things that it connects to. Plus it has wires that can talk back and forth with it, so that way they can communicate and you can get battery voltage information going back and forth, so it can tell it how much battery is left and so on and so forth. From the power module, we go to the power distribution board, which is here, and it takes in the positive and the negative in the ground terminal, and it sends it out to all of the propellers and the motors, evenly to all of them. And so as we come over here, you see there's a positive and a ground that goes to the electronic speed controller, which regulates the speed for each motor. And electronic speed controllers can have BECs, but most of the time our power module will act as a BEC, so battery eliminator circuit, and it will step down the voltage, so that way the electronic speed controllers, we don't have to have one of them we don't have to have a BEC on each of our speed controllers that will be around this, but instead it's all controlled right here so that these don't have to worry about it. And they also communicate with the flight controller to tell how much voltage should be going back and forth to the motor. And it also changes it from a direct current line two alternating current lines coming out on these 3 leads that lead to the motor. And the motor spins, and then we can switch any 2 of these if we want the motor to spin the opposite way. And yeah, that's my power system. And for my references / works cited, I have them all listed right here.